Hello friends, today's topic is Bipolar Junction Transistor Characteristics. First, some introduction of the transistor characteristics, the detailed description of common base configuration, input characteristics, output characteristics of common base configuration, some important parameters of common base configuration. Transistor characteristics. Transistor characteristics are the plots which represent the relationships between the current and the voltages of a transistor in a particular configuration. By considering the transistor configuration circuits to be analogous to two-port networks, they can be analyzed using the characteristic curves which can be of the following types: input characteristics, output characteristics, current transfer characteristics. First, input characteristics. Input characteristics describe the changes in input current with the variation in the values of the input voltage, keeping output voltage constant. Output characteristics. Output characteristics is a plot of output current versus output voltage with constant input current. The third one is current transfer characteristics. This characteristics curve shows the variation of output current in accordance with the input current, keeping output voltage constant. Common base configuration. In common base configuration, emitter is the input terminal, collector is the output terminal, and the base terminal is connected as a common terminal for both input and output. That means the emitter terminal and common base terminal are known as input terminals, whereas the collector terminal and common base terminal are known as output terminals. In common base configuration, the base terminal is grounded, so the common base configuration is also known as grounded base configuration. Sometimes common base configuration is referred to as common base amplifier, CB amplifier, or CB configuration. The input signal is applied between the emitter and the base terminals, while the corresponding output signal is taken across the collector and base terminal. Thus, the base terminal of a transistor is common for both input and output terminals, and hence it is named as common base configuration. The supply voltage between base and emitter is denoted by VBE, while the supply voltage between collector and the base is denoted by VCB. As mentioned earlier, the base emitter junction JE is always forward biased and collector base junction JC is always reverse biased. Therefore, in common base configuration, the base emitter junction JE is forward biased and collector base junction JC is reverse biased. The common base configuration for both NPN and PNP transistors are shown in figure. From the diagram, it can be seen that for both NPN and PNP transistors, the input is applied to the emitter and the output is taken from the collector. The common terminal for both the circuits is the base. Current flow in common base amplifier. For the sake of understanding, let us consider NPN transistor in common base configuration. The NPN transistor is formed when a single p-type semiconductor layer is sandwiched between two n-type semiconductor layers. The base emitter junction JE is forward biased by the supply voltage VBE, while the collector base junction JC is reverse biased by the supply voltage VCB. Due to the forward bias voltage VBE, the free electrons, majority carriers, in the emitter region experience a repulsive force from the negative terminal of the battery. Similarly, holes, majority carriers in the base region experiences a repulsive force from the positive terminal of the battery. As a result, free electrons start flowing from the emitter to base. Similarly, holes start flowing from base to emitter. Thus, free electrons which are flowing from emitter to base and holes which are flowing from base to emitter conducts electronic current. The actual current is carried by free electrons which are flowing from emitter to base. However, we follow the conventional current direction which is from base to emitter. Thus, this current is produced at the base emitter region. The free electrons which are flowing from emitter to base will combine with the holes in the base region. Similarly, the holes which are flowing from base to emitter will combine with the electrons in the emitter region. From the diagram, it is seen that the width of the base region is very thin. Therefore, only a small percentage of free electrons from emitter region will combine with the holes in the base region, and the remaining large number of free electrons cross the base region and enters into the collector region. A large number of free electrons which entered into the collector region will experience an attractive force from the positive terminal of the battery. Therefore, the free electrons in the collector region will flow towards the positive terminal of the battery. Thus, electric current is produced by the collector region. The electric current produced at the collector region is permanently due to the free electrons from the emitter region. Similarly, the electric current produced at the base region is also primarily due to the free electrons from the emitter region. Therefore, the emitter current is greater than the base current and collector current. The emitter current is the sum of base current and collector current. IE equal to IB plus IC. We know that emitter current is the input current and the collector current is the output current. The output collector current is less than the input emitter current. So, the current gain of the common base amplifier is actually less than 1. In other words, the common base amplifier attenuates the electric current rather than amplifying it. The base emitter junction JE at input side acts as a forward biased diode. So, the common base amplifier has a low input impedance. On the other hand, the collector base junction JC at the output side acts somewhat like a reverse biased diode. So, the common base amplifier has high output impedance. Therefore, the common base amplifier provides a low input impedance and high output impedance. Transistors with low input impedance and high output impedances provide a high voltage gain. Even though the voltage gain is high, the current gain is very low, and the overall power gain of the common base amplifier is low as compared to the other transistor amplifier configurations. The common base transistor amplifiers are primarily used in the applications where low input impedance is required. The common base amplifier is mainly used as a voltage amplifier or current buffer. This type of transistor arrangement is not very common and is not as widely used as the other two transistor configurations. The working principle of PNP transistor with the common base configuration is same as the NPN transistor with this common base configuration. The only difference is in NPN transistor, free electrons conduct most of the current, whereas in PNP transistor, the holes conduct most of the current. To fully describe the behavior of a transistor with common base configuration, we need two sets of characteristics. They are input characteristics and output characteristics. Now we are going to see the input characteristics of the common base configuration. The input characteristics describe the relationship between input current IE and the input voltage VBE. First, draw a vertical line and horizontal line. The vertical line represents y-axis and the horizontal line represents x-axis. The input current or emitter current IE is taken along the y-axis vertical line and the input voltage VBE is taken along the x-axis horizontal line. To determine the input characteristics, the output voltage VCB, collector base voltage, is kept constant at 0 volts and the input voltage VBE is increased from 0 volts to different voltage levels. For each voltage level of the input voltage VBE, the input current IE is recorded on a paper or in any other form. A curve is then drawn between input current IE and output voltage VBE at constant output voltage VCB. The figure shows the input characteristics of a common base configuration. Next, the output voltage VCB is increased from 0 volts to a certain voltage level and kept constant, say 8 volts, as shown in the figure. While increasing the output voltage VCB, the input voltage VBE is kept constant at 0 volts. After we kept the output voltage VCB constant, the input voltage VBE is increased from 0 volts to different voltage levels. For each voltage level of the input voltage VBE, the output current is recorded. A curve is then drawn between input current IE and input voltage VBE at constant output voltage VCB, say 8 volts. This is repeated for higher fixed values of the output voltage VCB. When output voltage VCB at 0 volts and emitter base junction JE is forward biased by the input voltage VBE, the emitter base junction acts like a normal PN junction diode. So, the input characteristics are same as the forward characteristics of a normal PN junction diode. The cut-in voltage of a silicon transistor is 0.7 volts and germanium transistor is 0.3 volts. In this case, it is a silicon transistor. So, from the above graph, we can see that after 0.7 volts, a small increase in input voltage VBE will rapidly increase the input current. When the output voltage VCB is increased from 0 volts to a certain voltage level, say 8 volts, the emitter current flow will be increased, which in turn reduces the depletion region width at the emitter base junction. As a result, the cut-in voltage will be reduced. Therefore, the curves shifted towards the left side for higher values of the output voltage VCB. Output characteristics of common base configuration. The output characteristics describe the relationship between output current IC and the output voltage VCB. First, draw a vertical line and a horizontal line. The vertical line represents y-axis and the horizontal line represents x-axis. The output current or collector current IC is taken along the y-axis vertical line and the output voltage VCB is taken along the x-axis horizontal line. To determine the output characteristics, the input current or emitter current IE is kept constant at 0 milliamperes and the output voltage VCB is increased from 0 volts to different voltage levels. For each voltage level of the output voltage VCB, the output current IC is recorded. A curve is then drawn between output current IC and output voltage VCB at constant input current IE. When the emitter current or input current IE is equal to 0 milliamperes, the transistor operates in the cutoff region. Next, the input current IE is increased from 0 milliamperes to 1 milliampere by adjusting the input voltage VBE, and the input current IE is kept at 1 milliampere constant. While increasing the input current IE, the output voltage VCB is kept constant. After we kept the input current IE constant at 1 milliamperes, the output voltage VCB is increased from 0 volts to different voltage levels. For each voltage level of the output voltage VCB, the output current IC is recorded. A curve is then drawn between output current IC and the output voltage VCB at constant input current IE say 1 milliamperes. This region is known as the active region of a transistor. This is repeated for higher fixed values of input current, i.e., that is 2 milliamperes, 3 milliamperes, etc. From the above characteristics, we can see that for a constant input current IE, when the output voltage VCB is increased, the output current IC remains constant. At the saturation region, both emitter-based junction JE and collector-based junction JC are forward biased. From the above graph, we can see that a sudden increase in collector current when the output voltage VCB makes the collector-based junction JC forward biased. Early effect. Due to forward bias, the emitter-based junction JE acts as a forward bias diode, and due to reverse bias, the collector-based junction JC acts as a reverse bias diode. Therefore, the width of the depletion region at the base emitter junction JE is very small, whereas the width of the depletion region at the collector-based junction JC is very large. If the output voltage VCB applied to the collector-based junction JC is further increased, the depletion region width further increases. The base region is highly doped as compared to the collector region. So, the depletion region penetrates more into the base region and less into the collector region. As a result, the width of the base region decreases. This dependency of base width of the output voltage VCB is known as early effect. If the output voltage VCB applied to the collector-based junction JC is highly increased, the base width may be reduced to 0 and cause a voltage breakdown in the transistor. This phenomenon is known as punch-through. Next, we are going to see the transistor parameters. The transistor parameters, here we are going to see dynamic input resistance, dynamic output resistance, current gain. First, dynamic input resistance represented by Ri. Dynamic input resistance is defined as the ratio of the change in input voltage or emitter voltage VBE to the corresponding change in input current or emitter current IE, with the output voltage or collector voltage VCB kept constant. Ri equal to del VBE by del IE, keeping VCB constant. The input resistance of common base amplifier is very low. Next, dynamic output resistance represented by Ro. Dynamic output resistance is defined as the ratio of change in output voltage or collector voltage VCB to the corresponding change in output current or collector current IC, with the input current or emitted current IE kept at constant. Mathematically, R0 equal to del VCB by del IC, keeping IE constant. The output resistance of common base amplifier is very high. Next, the third parameter is a current gain alpha. The current gain of a transistor in common base configuration is defined as the ratio of the output current or collector current IC to the input current or emitter current IE. Alpha equal to IC by IE. The current gain of a transistor in common base configuration is less than unity. The typical current gain of common base amplifier is 0.98. So far we have discussed introduction of transistor characteristics, common base configuration, its characteristics, input characteristics, output characteristics, transistor parameters. Thank you.